Okay, now we're going to start studying object-oriented programming. This is actually unit 27 of your syllabus. And in this course, we'll be discovering basically what an object is. And if you remember the organization of uh, a record was in paper 3, we studied what a record is. This is user-defined type. In fact, we implemented records from paper 2 onwards. Now, if, for example, the problem at hand that you're trying to solve with your code does not allow you, the problem does not, it's not solvable with your basic data types, your integers, your strings, or your characters. Most programming languages allow you to create user-defined types. And in pursuit of user-defined types, one example that we studied was a record type, in which basically a record type is a non-composite data type in which you're creating a reference to at least 2 or more basic data types. So if you are missing the concept of records, I advise you to visit paper 2 concepts, and a video has been uploaded for that as well. Now, a record data type has references to fields. So basically, one record, for example, if I have an employee record can have employee name, ID, employee name, and possibly pay grade, so on and so forth. So I have 3 fields that are combined together to make one record for a field, a one record, right? Now, if, for example, I have this record. Now records have no additional options, just these 3 fields. These are its attributes. Now, an object, on the other hand, or a class, for example, on the other hand, is somewhat like a record, but it has additional features. One of the most prominent additional features that we have of a class is that these classes have these fields, just like a record. On top of that, these fields can also have additional methods. Now, these methods are basically functions that you can use to use those fields. Now, as you can see here, basically what happens is that when in object-oriented programming, there's a concept of encapsulation. So basically what that means is that if I say, for example, I have an object by the name of car, as you can see here, a car is not is a class type. A class of car will have all cars that all objects of type car will have these fields on them. So they will have these 1, 2, 3, 4, 5 fields. These will be their types, and a part of these 5 fields, we will have additional features which only object-oriented programming support, and these additional features will be the methods that I can use to access these attributes. Now, the reason that I have these attributes and these methods is that these attributes cannot be accessed without these methods, whatever they are. Why? Because object-oriented programming states that all of the attributes that you're using in a class, like I'm using these 5 attributes, this car class, these are private. Now, what it means by private is that if I have created an object of a car class, I'm using these terms object and class interchangeably. I will explain to you what the difference between object and a class is in a while. But for example, if I have created an object of car class, it will have these attributes there, but they will not be public information. What that means is that any other entity, any other object outside of one car class object cannot directly access these fields. As you remember in our record structures, we use the dot notation to access individual fields. So just for example, if I had, say, a record of employee type, so one employee, I declare new employee of type employee. So if you remember, we use this symbol for mentioning of type employee. Now imagine that each employee record has 3 fields. namely the employee name, employee ID, employee name, and employee pay grade. Now, as for a record, each each variable, in this case new employee of this type, all of the attributes of this record, namely the employee ID, employee name, and employee pay grade, are public information. So if, for example, I want to access one field of this record, I can simply use the dot notation. So for example, if I want to print the employee ID for new employee, I simply do what? New employee dot employee ID. If, for example, the field's name was employee ID, like so. So what I did here is that I accessed the employee ID field of new employee record and simply printed it. And I could do that very easily because employee ID and all other fields for a record are public, and you can easily access them through the dot notation. On the other hand, if this was an object, I could not do this with dot notation. I cannot access individual fields through this dot notation. I cannot do that. And what that means is this: all of these fields are private. So unless I use these methods, I have allowed for these methods to access these fields in a particular way. If I have methods to access these fields, only then I can access these fields. And these methods are kept public. So what that means is, just for example, let's just say there's a student in your class. He has a name. His name is, for example, John. Now, then his name John is not displayed on his face or anywhere, but it's mentioned inside. It's private information. Now, if it was public information, I did not have to access that student to access his name. I did not have to ask him. It would be there. It would be public information. I could simply access it myself. But since his name is private information, I have to, it's not visible to me. It's not publicly available. However, now I have methods to access his name. By that method, I mean that I can simply ask his name. So for example, if that student allows other people to ask his name, that would be a method which is publicly available. So I will use that method to ask his name. So if I am allowed to ask his name, I can ask his name, and only then he will reveal his name. And the method, the procedure of asking a particular student's name is public. Anyone can do that. But other than that, his name is not public information. It never is, it never will be, right? So this is one thing to consider here. In object-oriented programming, this allows me greater control over my data. So if I want particular fields to be revealed in a certain way, only I choose how to reveal them. Since all fields are private, if I have allowed for a method to access them, only then they can be accessed. Now, if, for example, that student which we're referring to as John, he was never given a method to show his name or tell his name. In a sense, you can say that when his creation, his upbringing, his class definition was when it was created, there was no part in his upbringing or his creation that allowed him to show his name. Basically, there was no method for his name to be made public knowledge. So that means I'm not even allowed to ask his name, because he will not recognize that method as well. So, but if that method is part of his definition, I have access to all methods are public. All of these methods, you see, methods are all declared public. Now, what object-oriented programming does is that it allows us, it grants us control over how our data will be accessed, what data is to be accessed, and in what way. Obviously, if I have added these fields, I will want them to be accessed. Otherwise, why do I have them? These data fields will be actually clogging up my memory when an object has been created. So if I don't want them to be used in any way, why would I have them? So I will want them to be accessed, obviously. But how are they to be accessed? That's what I am in control of. So I can allow a particular field to be changed, and I can allow a particular field to not to be changed, only to be revealed. So if, for example, I want this registration field as mentioned here only to be revealed, I will allow only methods that simply reveal registration. And no method here will allow for this registration to be changed. So because of this definition of here, no power, no other source can ever attempt to change the registration of a car here, because I never allowed this. My class definition doesn't allow. So the reason that we always go for object-oriented programming is because it allows for us for greater control over access of data. And basically encapsulation is the concept of here is that all of the data of my object are made part of a closed set. And by closed set, all of the data and subroutines are made part of one object. And part of that data attributes will be accessed only by the methods available to them. If I don't allow for particular attributes to be revealed or changed, I will not have methods to do so. So if that student John has a method to display his name or present his name, he can do that. But his upbringing or his class definition does not allow for anyone to change his name. So whatever you do, you will never be allowed to change his name. You can ask his name, but you will never be allowed to set his name. So like so, if you, for example, create a class, you are in control of what fields or attributes supposed to have. And most importantly, you are also in control of how those fields or attributes can be referred to. Can they be viewed only, or can they be viewed and changed as well? And if you have allowed for a particular field not to be changed ever, no matter what you do, no outside source can ever change it, because you only have those methods publicly available. No individual attributes can ever be publicly available. So if a method which you allowed allows you to access a particular field and change it as well, only then you will be allowed to change it. Otherwise you won't, right? So this is what encapsulation is. All your data is very controlled in a control. All data is made a complete set, and data, which are the attributes, along with the subroutine. And this complete set of information, it means attributes and subroutines, become part of any object that is created for a particular class. Now let's come to the difference between a class and an object. First of all, you can say that a class diagram, which kind of looks like this, is simply a description of what an object will look like. So let's just say I create an object of car class. So what that will mean is that this particular object will have 1, 2, 3, 4, 5 individual fields. And I will allow these different, forget the constructor for a while, we'll talk about this later. But I will allow for these different methods to act upon these different fields. So this is my class diagram. So this is basically an outline of what an object of car class will look like. Now, if I create an object, I physically instantiate an object. But what does it mean by physical instantiation? It means that basically I have created an object that actually now exists in my main memory. So that is an object. That is my first physical example of an object of this class of cars. So if now I have described something as being a car, that car is my physical example of this entire class. It will have all of the properties mentioned as such. It will have these attributes, and you can use these methods on these attributes. Every object that is created from this class will all have the same features. And the first example that I create, the first version that I create, which ends up in my main memory, will be my object. Okay. So as just to put things together, the difference between a class and an object is that the class is basically the outline, is basically the description of what is to come. And when I have actual physical example, and by physical example, I mean something that exists in the main memory that resembles all the descriptions mentioned here, that will be called as my object. So an instance of a class, an example of my class, something that exists in my main memory that follows all of these features. So I hope that's clear, the difference between class and object. And obviously, if this definition is clear, you should be guessing this right on your own. That first of all, you need to create a class. So basically, you have to create a description of what a class is. Once you have created that description of class, only then you can proceed on creating objects that resemble these features. It's not the other way around. You cannot create objects first. You have to create a class first. Okay. Now, what is a class? Before using an object, we need to define the object type. What are the types of data it will hold? What will be the attributes? All of these attributes are meant to be private. Okay. This object type is known as class. The idea behind object-oriented programming is that attributes can only be accessed through these methods. Attributes can be accessed only through these methods. These attributes cannot be accessed via the dot notation. If you can access them to dot notation, that means you're the public, and that's not possible here. Okay. Secondly, the direct path, which is the dot notation to each data, is unavailable. Attributes are referred to as private, and methods can be accessed. Methods to access the data are made available to the programmers. So these are public. So any other external entity that wants to access the attributes within an object have to access it through these methods. They are available to everyone. And what methods I make available is up to me. And I have to define that at the time of class definition. Classes are templates for other objects to come. So first you design the class. When a class type has been defined, it can be used to create one or more objects. And the process of creating multiple objects is known as instantiation. And by that means, I have created an example of this class or any class that exists in my main memory. So this is where we start off. Now, when designing a class, I have to decide on what attributes we want to store. So again, this description here depends on what type of problem you're solving. So we have to decide this beforehand. So for example, if in this particular example we see here, if I were to be creating a car class, it would have pre-decided that my car class will have these different attributes to it. Agreed. It could have something else as well. But let's just say it was decided an object of car class will have these attributes. So it's pre-designed. What we did is we want to decide on the attributes. In fact, not only we're deciding on the attributes, we're also deciding on their types. So for example, vehicle ID should be string, registration will be string, date of registration will be date, engine size integer, purchase price, currency, so on and so forth. So this is decided beforehand, the attributes, what their names will be and what their types will be. After that, we will decide on the methods, which is the second part of my class diagram, the methods. Now, mostly class definitions require methods to be divided into two parts. They are known as the getters and the setters. Now, by definition, getter methods are used to present data to any entity outside an object. So for example, if I'm asking John his name, the method I'm using to ask John his name is a getter method, which will cause John to present his name. So this is a getter method. So similarly, as you can see here, this get vehicle ID, get registration, get date of registration, what they will do is simply return a particular object's vehicle IDs. And you might have guessed, I will have to have getter methods for all attributes. I will at least have to have getter methods for all attributes. Setters another thing, but getters have to be there. Because if I'm not allowing for getters, that means these attributes will never be presented to you. They will be there whenever an object is being created. They will be part of the memory. They will be there occupying space in your memory, but I will not be accessed. I will be able to access them because I will not have getter functions. So why do I have them in the first place? So I will always need getter functions. The other type of method is setter function. Now these setter methods or setter functions or setter procedures allow me to make changes to particular fields. So as you can see here in this particular class diagram, I only have setter methods for purchase price, registration, only date of registration. So only 3 attributes I'm allowing for changes only, and the rest are all getter functions for all attributes. Now, this is where the control of object-oriented programming really comes in. My setter functions are only allowed for 3 attributes, which means that I am not allowing for my vehicle ID to ever be changed and my engine size to ever be changed. I'm in control of that. Since my class definition does not allow my vehicle ID and engine size ever to be changed, that means whatever happens, any external entity will not be able to, any programmer or any hacker or anything, will ever be able to change an object that was created with car class. You will never be able to change it because it was not allowed. My class definition does not allow it ever, and I will never be able to do it. So this is where your object-oriented programming control really shines. So I am in control of the methods. These attributes are private. I have these methods which are public. I choose what methods to be included in my class definition. They should be setter getter methods, but what methods, what attributes am I allowing setters for? I am in control. I'm only allowing purchase price, registration, date of registration to have setters. So that means any external entity may change these attributes as per their requirement. That's okay. I'm allowing it. But what I will not allow is vehicle ID and engine size to be changed. And for that, only getter methods exist. So this is what the difference between setter and getter methods is. Getter methods simply return the value in a particular field of an object, and setters allow me to change the values in individual fields as well. So I'm in control of what happens with that. Now, why do we use object-oriented programming? If you might have already guessed, it allows for more security, no doubt about that. The advantage of object-oriented program code is that it produces more robust code. So obviously, I'm in control of what data to be accessed. So therefore, if I have external threats to particular programs, those threats will not be able to allow changes in fields that I have not allowed changes for. If there are no setter functions, those setter functions will not be allowed, not be exploited, and no data will be changed. Now let's take, for example, in the banking world. If I were to, for example, approach a bank and start a new account for my bank, I would be allocated, say, a customer ID, which will be my bank account number, and I will be giving my name, which will be my account title. Now, there are other fields for an account as well. Say that could be your type of currency, dollar account, rupee account, what is it, the balance, starting balance that you're giving it, so on and so forth. Now, what happens here is that I have, say, mentioned 4 fields here: account name, account number, account title, account number, and account balance, and currency type. These are 4 fields. Now, if I should not, or nobody outside of this banking system should ever be able to allow my account name to be changed. They cannot replace my name with theirs. Secondly, they should also not be allowed to change my account number with theirs. They should not be allowed that. So the person who designed the banking software should keep this thing in mind. And if an object was to be created for each account holder, the class diagram would be designed in such a way that the attributes account title and account name will only have getter functions, but no setter functions, because I'm not allowing them to be changed. They can be revealed, but not changed. However, at some point I will be withdrawing money, adding money. In that case, my balance should be able to be changed. So I will have setter functions for that and getter functions as well. Similarly, I may choose to change the currency type for my account, in which case I will have a setter function there as that as well. If, say, there's another field such as an address from my account, I will have a setter function for that as well, because I may want to change, I may move from one place to another at some point. I may want to change the address as well. But what I will never want to change is the account title and the account name, because if those are allowed, some hacker might exploit, or some malicious user may exploit the setter functions for account title as well as account number, and replace it for any other account number or account title of their choosing. And when money is being transferred, it will be transferred in their name. So I will not allow for this. So if I don't want those things to be changed, I will not allow for setter functions. So it allows for more robust code. Attributes can only be manipulated using methods provided by class definition. If I have methods for setting, only then will be setting allowed. Otherwise, only getting will be allowed. If this means the attributes are protected from accidental and malicious changes. Classes provided in module libraries are thoroughly tested. So if you are making use of a built-in class in your code, these classes are, they have gone through several versions over the time, and they're thoroughly tested, and there's no mistakes in them, so you can very easily use them. If you have used tried and testing building blocks to construct a program, you are less likely to introduce bugs than when you write code from scratch. Object-oriented programming allows for one very important aspect in the development world, which is known as reusability. So what that means is that if I have created some code from one project, I may be able to use that code for another project. What that does is that eventually brings down the overall effort of programming, because you're including existing parts of your code. And if you have used object-oriented programming, you may want to involve previously created classes to another project, and thereby it's reducing your effort of programming overall. So that is one of the benefits of using object-oriented programming. Now, in the next lectures, we will look at an example of object-oriented programming. We'll be looking further into this car class. We'll see how the individual methods work, what their purpose. So we'll be looking at this, what you call it, identifier table. And we will look at how different class diagrams look, what these mean. And eventually we'll have to work on the Python version of this code, so that for your exam, you'll be able to implement this particular object-oriented programming concept with respect to Python or any other language of your choice.